Hello and welcome to part 2. If you haven't seen the previous video, I'm showing how to install ComfyUI, where to find models to download, and I assume that you've already done this or know how to do it. This is part 2 where we're getting comfy with the UI, so we're going to start from scratch. I'm going to click the little plus here. Or maybe first we take a look at the user interface in general. This is the new UI. And here you can revert back if you are familiar with the previous one, revert back to the previous one. This is what it looked like before. But we're going to work with the new one. So you can decide if you want to have it on the top or the bottom. Let's leave it at that now. Then we're going to make a new workflow, and either by right-clicking and selecting a node or by double-clicking, we're going to load a checkpoint first, which is the actual AI model that we have downloaded previously. So right now I have only one, otherwise there would be a long list here. This is a model based on Stable Diffusion XL, so we need to keep that in mind. And then you can drag out here that little thing, and the first thing we're going to do is to write a prompt. So we need a clip text encode, and we can write whatever we want to see. Let's say a portrait of a old man. And we can also do the same thing again and give it a negative prompt showing the things or naming the things that we don't want to see in the final result. For example, we don't like watermarks or blur or noise or whatever. Text maybe shouldn't be in there. So these things are negative prompts. And then there's two more things that we need to connect. Here, for example, we need to bring in a sampler. So we choose K-sampler. This is the thing where the magic happens, where all comes together. And the negative prompt and the positive prompt we can put in there right away. And then there's one thing left here. It asks for a latent image. A latent image is like a negative, if you're into analog photography. It's always how I like to describe it. It's an unexposed negative, so to speak. So we're putting in the resolution that corresponds to the model that we're using. As I said, Stable Diffusion XL. So it needs to be something around 1K in resolution. And then we will get, after the sampling, we will get an actual, this is empty, here's nothing in it, but we will get, after the sampling, a denoised image, a latent image, and we need to decode that into an actual image, because this is in latent space, so this is samples, it's not pixels. And we can then say we want to save an image or we want to preview an image. Let's do preview for now, which means it won't be saved. We just see it here. Later we can change that. And for now, we're going to go with that. So there's two things that are unconnected still. We will do this. This is the VAE, which is needed to decode the image. The latent image into a pixel image. And yeah, I guess that's basically it. We can run it and see what happens. Click the little run here, wait for it to load the model. That went rather quickly. And then the sampler does its job, and we will see our portrait of an old man. And yeah, I'm using the scroll wheel to zoom in and out, the middle mouse button to move. You can change colors here if you like of the different nodes. You can delete them. You can reroute things by holding the Alt key and then clicking and moving to tidy things up a little bit. For example, if you want to see where this is going, then you can easily move it around like this. Okay. The idea is to keep these workflows nice and clean so people, if they open it, can find their way. You can also, let's maybe take a look at the sampler a little bit more. There is a seed which the image is based on. You can put one in manually. I can enter one if I want. But it will randomize after every creation. And I want this to be always the same. I can put in fixed. So that means that every time I run the sampler, it will use the same seed, which means in the end I will get the same image again. If I rerun it now, nothing will happen because I didn't change any settings. But for example, if I play around with the CFG to figure out what that actually does, there's, by the way, always little tool tips. The CFG kind of, let me put it this way. There's a sweet spot with the CFG, which will produce the best results. It's a bit of creative freedom and prompt adherence that goes into that. So higher values might produce images that are closer to the prompt, but also might introduce artifacts, and lower values produce a bit more generic images. There's, as I said, a sweet spot for every model. So it makes sense actually if you're going to Civit AI and you're checking the models you're using. You will find some advice. Probably this is very slow this time. For example, here, let's just select that one. There will be some advice if you scroll down, recommended settings, here you will see. So for example, CFG 3 to 6 is recommended here. But now that I changed the value, if I rerun it, we will see the effect, and we will see a very similar picture because I just put the seed on fixed. So you can compare the effects it has. Yeah. So if I go up here with the CFG and run it again, you can go really high and you will see that it will produce artifacts that are not desired. And too low will also not be desirable. So find that sweet spot here. The steps are also very important. You need to know how the diffusion models work. They're basically trying to denoise a noisy latent image, and they're doing it in steps. So you can actually try to do it in one step, it will not work. There are models that actually work, but this is the result you will get when you do it in one step. So it will not fully denoise the image, but it will do it to a certain degree, and then it will try it with the already partially denoised image, and so on. So the more steps, the better probably, but also it will take more time. So if I put in 74 steps, it will take a very long time. And I would say probably after 30 steps, there won't be much of a noticeable difference. After this image is generated, I will go down significantly. So let's go to 30 now, and it will take a lot less time, and there will be hardly any difference. But if I go to, let's say, 15, there will be quite some difference. So I would say between 20 and 30 is here the ideal amount. Then there's different samplers. There's on the web you would find long lists of tests with different samplers, so you can actually figure out which one is your favorite. I would say Euler and normal. This combination is used very oftenly, but also DPM, PP, 2M, and Keras is also a combination that is used quite often. Will produce probably similar results. The denoise. This is what I said before. There is a noisy image, or basically an image that just consists of noise, which needs to be denoised. This value is should always be 1 if you're doing text to image, which we're doing right now. It's all basically based on the prompt. So this empty latent image needs to be fully denoised into that image. But if you're doing image to image, you could, for example, input an image, convert that into latent space, and then denoise it only partially. That would result in that would basically be a workflow, an image to image workflow. Yeah, but I guess this is it. You can save your workflow here and give it a nice name. My first workflow. And maybe we try saving an image. We didn't do that before. Those are just previews. So save image. And it will only save the image when you run the workflow again. So let's do that real quick. And the next thing is finding that image. Where the hell is it? You go to your ComfyUI path where you installed it. And then under ComfyUI output, you will see your first saved image. And it's 124 by 1024 by 1024, so you might want to process that later, upscale it or something like that. Yeah, what else is there to know about the interface? I don't think there's much. Here you will find your workflows, the one you just saved. Here you can see your models that you have in your install folders, then the nodes that you can use. Probably you can drag them from there, which is quite nice. Yeah, I guess that's basically it. Ah, yeah, maybe one more thing. This might be interesting. If you want to mass produce things, you can change this here, for example, to run on change. Let's try that. So whenever I change the seed here, for example, it will create a new image. Or I will go here on increment again. Again, I changed something in the UI and it created the next. And again, the seed was changed because it's on increment now. So it will produce more and more images with these settings. And you can also tell it to run infinitely. This might be useful in some cases. Let me go back to fixed. So this is the last seed now. And it's running, but it's not doing anything actually because there's no change here. But for example, I could now, yeah. Oh, maybe something else is interesting here now. You can change how many you want and run them. You know, they will produce. I mean, with the same settings, of course, it doesn't make sense. So let's put that on randomize and say 2 images, and he will run twice. If you have a very long queue, you can stop it here, clear pending tasks, and cancel current run. So let's say you put 32 or I don't know 50 in here. You click run. This will cancel the current run. You see it doesn't finish producing that image, and this will kill the whole queue. So all the tasks are gone. He's not making the 50 images anymore. Yeah, I guess that's about it. This you can move if you want and put it somewhere here, for example. You want it to stay always in foreground, of course. Okay, I'd say let's load a workflow, and you can get one from my Civit AI. I'll put the link in description. So let's download this real quick. So when you download workflows, okay, so when you download workflows, you can just bring them in by dragging and dropping them in the user interface. You can just drag and drop them in. So you go like this, and then you will see that there is a lot of missing nodes. This happens probably all the time when you're getting the workflow from somebody else, because they're using custom nodes, and you can install them easily by opening the manager, and then you install them one by one. This won't take too long because they're not big. Downloading models, of course, takes a long time, but the nodes are usually pretty small. There's always a link here. It comes mostly from GitHub. And when they're all installed, you have to restart. Okay, so we're done with the updates, and now we can close this and frame everything in here. So you see this is a long thing. Actually, there is one thing missing. It's a bit weird. So let's go into the manager and check if there's anything missing in the custom nodes. Check missing. Yeah, for some reason this wasn't installed, or it's not the latest one. Actually, I think we might want to refresh the interface. Let's reload. Yeah. Now it's all there. Okay, so this is like a basic tutorial where we have all kinds of use cases for ComfyUI. I'm showing you a text-to-image thing here. So you go from the top to down all the way through. So we start with this one, text-to-image. This is basically what we've just done. So pretty much the same setup. Here's some prompting advice. For example, if you want to have random values, you can do it like this. It will create a girl, a dog, or a man, but totally random. And here, for example, the red is a bit decreased in weight. So it might be a little bit red, but one would be if you put one, it's identical as if it's just this, you know. And you can raise and lower those values by hitting control arrow up or arrow down like this, and then you can quickly change the weights. Yeah, the rest is pretty much like we had it. CFG is quite low. I'm going to raise that a little bit. And then let's try and run it. And there is a slight problem because this model is not available. We didn't download it yet. So one way to do it is with many models, you can go into the manager and you can search for models here. So here's the model manager. And if I put albedo, nothing happens because this is a community model. So you won't be able to find it here. It comes from Civit AI. So let's go here and type here albedo. And it's actually this one. Let's download it real quick. So again, let's be sure that we use the safe tensor file when we download it. It's just one file here. Download. And we're going to put it here in this folder. Okay, download is finished, so I'm going to copy it here, move it here. And then we go back to the thing. And if I start it now, let's run it. It still has issues. Let's reload it and run it. Still doesn't like it. Yeah, the reason is it's looking for the thing in the SDXL folder, and it actually makes sense to do it like this. You can make a folder here, highly recommended, because it's going to get messy after a while. Name it SDXL and copy all SDXL based models in that folder. Let's try again. Still the same error. Let's reload again. Okay, so obviously the name was not 100% identical. It was maybe a different version. But if you click here, you can just select one of the models. And if I run it now, it should run without a problem. It reads the prompts, it samples, and it's just going to preview an image. So let's go to the next one. We turn that off and image to image. Let's take a look at that. It's actually, I always mark the nodes in red, which are new. So the rest is familiar. Again, we need to select the right model. We can actually also try the other one. Doesn't make much of a difference. So then we're going to need an image here, and we have that default image that we could use, of course, which comes with Stable Diffusion, but you can also put input images if you want in that folder here. Right now there's only this one, so feel free to put your input images there. But the other way you can do it is you can just drag and drop. Let me see if I can quickly find an image. Just drag and drop one in here. That's no problem. It will get copied to your ComfyUI folder. And yeah, let's leave that prompt. It says a cavern photo. What happens here, it will reduce or change the resolution of that image to roughly 1.5 megapixels. I will give it 1 megapixel. So I don't know what actually I do, it says here, but so the resolution actually won't change in this case. But if you're dragging a high-res image in here, that might make you trouble. It needs to be scaled to the proper size. Roughly around 1K. Then we will have an encode. So this pixel image will be encoded into latent space, and then it will be denoised. Before we had the value 1 in this workflow, because we have an empty image, and this empty latent image is just consisting of noise. It needs to be fully denoised to get an image. If we do the same here, it will probably produce a pretty... Let's just try it. Let's run it. It will produce a cavern photo, definitely. So you see, there is very little resemblance between those two pictures. Actually, we can see if there's a compare node. Just to learn something new here. And we can, from the VAE decode, we can plug that here and plug that here, get rid of that preview image. And now let's run it again. Actually, we're going to change a little bit the settings now. We're going to denoise it, not fully, just partially, and run it again. Make this a little bit bigger. So now you see this is a new image. And because it's image to image, he cannot turn this image into a cavern, you know, because we told it to denoise it only partially. So the original image has a lot of influence on the result. I can even make it... Let's try to produce a cavern again by raising the value here to 0.9. So we have the cavern is there. The seed is on fixed, that's why it's pretty much the same cavern. Let's try to find a sweet spot where we see the similarities between those images. Yeah, let's try something else. Let's make it a photo of a man, so we have a little bit more similarity. At least it will be a human, and see what that brings us. So this is, because it's a human, this is rather easy, you know. Let's see a little bit more a little bit less denoising. So it will be more similar to the original one. It's so close, actually, it's not a man anymore, and but it's still a new image. Yeah, this is basically image to image. So it might be interesting to try to put in some abstract stuff, and let's maybe do this real quick. So let's put in this one and see what will happen if we prompt it to produce a man. So you see the similarities between those two pictures. Okay, let's move on to the next one. Turn that off. The next one is interesting because we are loading a checkpoint again. Let's pick that one first, and let's just run it and see what happens. Again, we get an error that a LoRa is missing. And what is a LoRa? A LoRa is a small model that is attached to the base model. So the one we're using here was something called Zelensky. And it was based on Stable Diffusion. It is based on Stable Diffusion XL, of course, because there was an SDXL base model. So it's not this one. Let's see. That looks about right. So this is based on SDXL, and let's quickly download it. The idea of using LoRa's is that you can modify the results of your base model, but they're very small, so it doesn't take up much space in VRAM. It also doesn't take up much disk space, and this time you need to copy them to a different folder. You go to Models, LoRa's. And again, I recommend giving it folders. So SDXL, because it is a LoRa based on SDXL. And then you just copy or move it in there. And let's try to run it. It loads it nicely. And this is again text to image, but this time it will be, the base model will be influenced by the LoRa. And we get a picture of Zelensky. CFG is quite low. Let's put it a little bit higher and run it again. Important note about the LoRa's, there's always or mostly a trigger word that you need to put in the prompt, and they are written usually on the websites where you get them. So these two prompts, you can use them, you can copy them, and you can put them in the description. Either one of them works fine. And you notice also Zelensky is written with one Y here. The seed is again fixed, so if I rerun it now, you might get a slightly different result because the prompt is changed and I also changed the CFG. Yeah. So you can change the strength of the LoRa here. So reduce that to 0 and you will get only the result from the original checkpoint. So let's take a look what the original checkpoint, what the original model thinks Zelensky looks like. Maybe it knows him. No, I think it knows him. So there was some images of Zelensky in the training data, but it doesn't work very well with that base model. We can try the other base model that we downloaded earlier. But it shows why you need those LoRa's, because sometimes the base model alone doesn't produce the results you desire, and the LoRa's can be trained quite easily. You can train them yourself if you want specific characters in your creations. So that was LoRa. There's also, if you want to use multiple LoRa's, there's also different LoRa loaders that you can use. There are some, I don't have them installed here right now. There are some that let you load multiple LoRa's at the same time. So the next one is Inpainting. Inpainting, you again need an image that you want to modify. Let's see if we use this one again. So you put an image in here, and then you will open the mask editor. And then you can, in the mask editor, you can paint the part that you need changed. For example, if you want this to be a full robot face, then we just erase the human face. And we like the rest. We want to keep the rest. We don't want a completely new image. And we say a robot. What's very important here is we can't work with these models that we used before. We definitely need an Inpainting model. And they're kind of hard to find for Stable Diffusion XL. Much easier for the Stable Diffusion 1.5, and also for Flux. They're rather hard to find. There are not many out there. But I think Juggernaut has one, and we need to look around here a little bit. It will say Inpainting here somewhere, I guess. So it's this one that I used. You can download it here, or you could try this Inpainting model, which is, I guess, one of the original Inpainting models for Stable Diffusion XL. I will put the links again in the description, and once you copied it to the right folder, so it also goes to the, let me see, to the models folder. So you go here again, ComfyUI, models, and it's a checkpoint, so it goes in here. You can make if you like, an Inpainting folder like this, SD XL Inpainting, for example. And then you copy it in there. Quickly reload the interface, and here it is. So very important for Inpainting. You can do it with other models, but it will look really bad. So you need definitely an Inpainting model, and in this case it will try to make a robot face. Now let's see what happens. Just run it. Of course, I'm showing all of this pretty much with bad models here right now. Those are not very popular ones. So you probably these days you would want to work with Flux, but it's very resource hungry. So for demonstration purposes, for learning, it's quite okay to use the SDXL models. But if you want to produce really good results, this is probably not the way to go. I will show that later, but definitely you can do Inpainting with Flux now, which is more, yeah, a better idea, I'd say. Yeah, but in theory, you see it's working. Let's move on to the next one. Turn off the Inpainting and go to Outpainting. So with Outpainting, you're actually doing Inpainting, but you're extending the image before you do the processing. So we have an input image here. Let's take the same lady again. And at the bottom, maybe we will add some pixels. Let's say 500 pixels at the bottom. 0 at the top, and there's a rescale here to 1 megapixel, so that makes sense. It's hidden behind. Okay, and run it. Again, we get that error because we need a model chosen here. Again, it needs to be an Inpainting model, because this is also, even if it's called Outpainting, it's actually Inpainting. And the prompt is futuristic city right now, which doesn't make sense for this picture. We will probably see a futuristic city now, but thank God it's not. It's trying to make sense of the image as well. That's what the deal is with those Inpainting models. So we don't see much of a city here. See a little seam that probably can be fixed if we tweak the image, the values here a little bit. Yeah, but you see, that's basically it. You add something to the image, and that's what we call outpainting. Let's call it a robot body, or maybe female robot body. Let's try that again. Yeah, that somehow got worse. Let's get rid of the female and let's try random seeds so we get different results. Again, this might be a good thing to try the negative prompts, so we don't want to see skin. Okay, so that's for outpainting. Let's move on to the next one. Oops. So the next one is ControlNet. This is going to be a bit more complicated, I guess, because we need even more models. We need ControlNet models. We need base models. So now we don't need Inpainting models, so this can be one of the previous ones. And here is a ControlNet model, which is for depth. So it says diffusers XL depth. Let's see if we can get that through the manager. So let's check. There is a model manager, and it was called XL depth diffusers. XL depth. Let's try this one. And we're also going to need a model that will help us with depth perception. Let's install that one. So let's bring in the ControlNet that we just downloaded here, and let's run, let's run the we need to bring in an image, of course. So let's use the same one that we had previously. It says Cyberpunk Cityscape at night. Yeah, so we have a portrait and we are asking for a city, but let's not do that. Let's again give it a prompt, a human. We definitely want. Okay, let's run it, and he's going to analyze the image now, and he's going to make a black and white image representing the depth. Black is in the background, white is in the foreground. You can use different models than Midas. This doesn't necessarily change bring the best, results, but this will drive now the creation of the image. So we will definitely get a result that has the same proportions and the same composition. And actually it's already stopping quite early. So this value you want to change if you have a 1 in here, it will remain through the whole creation process under the influence of that black and white image. So this will be even stricter if you have settings like this. Let's try again. It's already very close to that. It will adhere maybe even more to it now. See, those are almost identical. And you can of course not make it into a city, but we can, for example, try a vase or something that has a similar shape and see what happens. It will still look like a human because we force it to adhere to that three-dimensional shape basically. But if we say, okay, it's doing steps here, for the first, if we say it will take 20 steps, denoising steps. If we say 0.5 here, for example, it will only influence the first 10 steps and then it will stop. Let's see what that looks like. So it looks much more like a vase already. Let's say 0.2. And in the negative prompt, we could actually put a human. So it tries to adhere to that shape a little bit. Let's go higher again. Should get closer to that shape again. But it probably will not try to make a human. Yeah, but this looks very much like a human, so it's a bit contradictory, of course. But you get the idea. This black and white image drives the shape of the final output. And that's ControlNet with depth. Let's real quickly take a look at ControlNet and what it does. I'll put again the link in the description. So that's the, there must be a GitHub link, yes. This is the source of that model, of these models. And if you scroll down here a little bit, you can see different examples. What kind of control nets are there? There's Canny. This is based on Stable Diffusion 1.5, but to some degree it will be available for later models. So you have Canny, which produces outlines. And similarly, you will have a driving photo, an original basically, that will be transformed into this Canny image, and this drives the composition of the generated images. Another example for Canny, then you have LSD lines. HED boundaries. So those are the intermediate images here, the original photo and the generations that are based on it. There's also a Scribble version, so you can input a drawing and use that to drive your creations. It can even be simple as this. And there's also another model, Openpose, which is very useful to posing characters. So let's go back to the next one and deactivate depth again and take a look at Openpose. Again, you need an input image. Let's take this one. And the prompt is, I guess, fine for now. So the difference here, again, we need to find another model. It's called this is actually wrong. Should of course be an Openpose model. Okay, yeah. If you make those a little bit wider, you can actually read what the name of the model is. So it's ControlNet Openpose SDXL. Again, we can get this over the manager, I guess. So you go to model manager and type in Openpose. And use this one. Refresh. And back, close this. And then we should be able to select it. So the Openpose one, not the depth. And let's see what happens. When something is not working, you will get a red outline, and you need to actually load the model here, the base model. And run it again. But already you see he tried to figure out the pose of that character, and you can enable or disable if he's supposed to look at hands or body or face. I always say he, but it's it probably, huh? Yeah. And I guess this depends on the Openpose model. I guess this doesn't match here fully, so the character is reversed. Usually the color of the arms will indicate if it's the right or the left arm. In this case, we see the back of the person. So we could try another Openpose model here. Let's do it real quick. Refresh again, close, back, and let's choose the other one. Let's see what happens. So he's loading the model again, and let's see if it produces what we want. Yeah, so now the face is in the same position and arms more or less. It's not a very nice image though, so we might play around with some values, but this is just to show the principle. I guess that's good enough, and we move on to the next one. Okay, next one is style transfer. So again, we are going to need a bunch of models. So I guess the first one we're going to need is the IPAdapter for style transfer. Let's try it again over the model manager, and we're looking for VIT. It's this one, IPAdapter plus SDXL VITH. So this one, click install. And while it's doing this, we can also search for a clip vision model. I guess that one should do the trick. And hit install. Go back and close. So now we're going to need a, first of all, let's select here the SDXL we previously used, and we need, of course, a reference image for the style. And Let's try this one. So this is what the style should be like. So it's not a photo, it's a illustrative style, and the prompt is okay. Let's see if it works if we run it. And there you have it. So it's a different new image that takes the style out of that. It says here style transfer, but for example, the shirt is not green right now, even though we prompted green. We can change that to prompt is more important and see what happens. Yeah, so that works nicely. Let's move on to the next one, which is IPAdapter again, but this time with FaceID. So yeah, let's take a face as a reference. Maybe this guy looks a bit unhappy. Again, a base model. And now we need a clip vision model, which I don't think is actually there, but let's leave it for that. And IPAdapter FaceID plus V2. Again, let's make it a little bit bigger so we can read it SD Upscale. Let's do it over the model manager again. FaceID. Let's install, sorry, that's not the right one, this one. Let's install this one. And refresh. And back and close again. So we now have two. The one we used previously for the style transfer, and now we have another one for the FaceID. And let's see if it works if we run it. So you see the prompt now is just wearing a lab coat and a green t-shirt. So I expect this face on a guy wearing a lab coat and a green t-shirt. Okay, it seems we need the right version for Insightface. There is a website, I will put the link in the description again, and it offers different versions of Insightface. And what you need to do is you have to figure out which Python version comes with your flavor of ComfyUI. So what you do is you go in your ComfyUI folder, and here you will go to the address bar and you will enter CMD. It will open a new terminal window. And what you're going to type in here is Python embedded / python.exe -v, a big V, and then you see the Python version that is in that Python embedded folder. So I have 3.12 here, so 3.12. So I'm going to download, sorry, where was the website? Didn't I have it open anymore? Okay. So I have to download the right file for 3.12. So this is the one I want. Just download it and place that file in that ComfyUI portable folder. So back to the command window. Next thing you're going to do is you're going to type in this, Python embedded, python.exe pip install. All the text you can just copy and paste it from the description. And then we're going to install the right version of Insightface, the one we just downloaded. Just copy the file name from here so you can be sure it's the right one. Yeah, and I hope that's it. You can restart it again after that. And let's try. Yeah, and he still looks very unhappy. And you see the green t-shirt, the lab coat, everything as expected. Might be a good idea to put in a neutral face. Let's try if we can prompt a smile in his face, but not necessarily this will work. Yeah, so basically this is Face ID. Okay, much better. Yeah, so on to the next one. Now it's a bit about upscaling because the images we're producing are fairly low res. So let's take a look at upscaling. If I run this, first of all, I need an input image again. Maybe let's take this guy again. All right, this needs to be upscaled. Here is usually the model selected and it says undefined. So we need to get an upscale model. Let's do it again with the manager, model manager, and look for foolhardy. And there we have it. This is one of many upscaling models. Let's quickly install it and refresh, back and close and close. Here's also a link, very useful, to a model database, which is dedicated to these kind of upscaling models. Those are not diffusion models, kind of different, and you can choose yourself depending on what you're doing right now, which one will work best for you. This foolhardy one is works good on photos, so we're going to use that one. And here again we have a compare node, so we can see both images, the original and the upscaled one, side by side. And again we get a little error message because we didn't pick the model here. Let's run it. This goes rather quickly. And there they are. The original one and the upscaled one. So it's a bit crisper. The resolution is 4 times higher. It might work for some use cases, but there are other ways to upscale things. Another way is to do a latent space upscale, which I rarely use. You can, let's put in the same image again. You can, I guess this one model is probably also missing, I could imagine. Let's see what happens. So this is new. Florence is an AI that will create a caption for this image. So we don't have to prompt manually. Because there will be sampling again, we need to tell it what to produce, because there will be denoising and we need to give it a goal. And the text here is not entered manually, the positive prompt, but it comes from this Florence model, which will take a look at this image, describe the image, put it in the positive prompt. It will be encoded into clip and then fed into the sampler. And the negative prompt is, as before, what we don't want to see entered manually. The image itself will be encoded into a latent space again with a variational autoencoder, and then in latent space it will be upscaled by only 1.5 150%, which is not much, but it's not easy to make a good or an extremer upscale. And then the latent space, the latent image, which is upscaled now, is fed into the sampler, which is denoising it again, and we get a result. Let's try it. Yeah, so this took a little longer because it was automatically downloading the Florence model. This is of course nice when nodes do that download and load model. That should be more often the case. So only the first time you run this workflow, it will be a little bit slower. So actually this is quite fast, this workflow. But you see, it may be fast, but the results are quite different. So you see, this is the slightly blurrier one, and 1.5 scale is not that much higher than we would like it to be. So this is not the best way to go. Let's take a look at the next one, Ultimate SD Upscale. That's a good one. Again, same input image. And again, we are sampling, so we need a model here. And the prompt, again, is provided by Florence. So it will take a look at the picture and it will describe it. It will be encoded into clip. And this time it will sample it in tiles. So this is the new node here that we didn't use before. This is the sampler, but it also splits up the image into different tiles. And we define the end resolution of those tiles. Since it is an SDXL model, 1K would be the best resolution here. And again, you have the typical things, CFG, the steps. We're upscaling by 4, so this is much better than the 1.5 we had previously. And it would be nice, which is not the case right now. So if it's taking chunks of these things, maybe there is a solution for this, but this is just, again, an example. If he takes a tile out of this and there is no face in it, for example, but we get a prompt, a caption for the entire image, it might produce images in every tile. That might, of course, faces in every tile, which might be, of course, problematic. So you might end up with multiple faces. It would be much smarter to describe every tile separately. But this is an advanced workflow, and we're going to keep it simple here just to think about the possibilities that we have. So let's run it. This will be quite slow because he has to make a bunch of images at the same time, produce a bunch of 1K images, and then in the end stitch them together to a final output. Would also be nice to actually see here what's going on. So let's go into the settings, into the manager, and we're going to change the preview mode to latent to RGB. Then we can see here what's going on. So he's working on one tile after the other. He picks 512 by 512 tiles out of this and then upscales it to 1K. And for this also very, very important, the denoising. This is how different it will be from the original image. So if it's too low, this value, you might still get the low resolution of the original. If it's too high, it might be too different from your original image. So this is the caption that Florence came up with. Quite simple. There we go. If we zoom in, this is the original quality, and this is the upres one with stable diffusion upres. And it's interesting because it uses also an upscale model that we've seen previously. So it will basically upscale with this model and then do an image-to-image process with this denoise value. So sometimes you will get some artifacts that look like the upscale from foolhardy. Okay, I guess that's basically it. We're done. Thanks a lot, and I'll come back later with more advanced tutorials.